On April 23, 1967, Vladimir Komarov walked out onto the concrete of the Baikonur Cosmodrome. He was 40 years old. He was a hero of the Soviet Union, and he was a man walking to his own funeral. As he looked up at the massive Soyuz 1 rocket, Komarov wasn't filled with hope. He was filled with dread. He knew, with terrifying certainty, that the machine waiting for him was defective. Engineers had found over 200 structural problems during pre-flight testing. They knew the parachutes were undersized. They knew the power systems were faulty. Yet, Komarov strapped himself in. He checked the dials. He prepared for launch. Why? Why would a rational man knowingly step into a death trap? The answer is a friendship that defined the space race. Komarov's backup pilot was Yuri Gagarin, the first man in space, the poster boy of the Soviet Empire, and Komarov's closest friend. The authorities had made it clear, if Komarov refused to fly, Gagarin would go in his place. Komarov could not let his friend die, so he climbed into the capsule to save him. Komarov's sacrifice is just one chapter in the blood-soaked history of space exploration. We often view the journey to the stars as a montage of triumphs, flags, footprints, and scientific breakthroughs. But the reality is far darker. The road to the heavens is paved with the bodies of those who dared to leave the Earth. From the frozen launch pads of Florida to the suffocating vacuum of low Earth orbit, space is unforgiving. Today, in this education documentary, we uncover the true stories behind the 5 deadliest space disasters in history. We will analyze the fatal technical flaws explained, the political arrogance, and the heartbreaking final moments of the men and women who paid the ultimate price. The Martyr, Soyuz 1. To understand the tragedy of Soyuz 1, you must understand the year 1967. The Cold War was at its boiling point. The Kremlin was desperate for a propaganda victory to celebrate the 50th anniversary of the Communist Revolution. They demanded a spectacular mission: launch Soyuz 1, then launch Soyuz 2 the next day, and have them dock in orbit. It was a mission dictated by politicians, not scientists. The Soyuz spacecraft was a complex new beast, far more advanced than anything flown before, but it was nowhere near ready. A 10-page memo detailing 203 specific defects was drafted by the engineering team. But in a culture of fear, no one dared to hand it to the Politburo. The launch date was set in stone. At 3:35 a.m., the engines ignited. Soyuz 1 roared into the night sky. For a few minutes, it looked like a triumph. But as soon as the ship reached orbit, the incident began. The spacecraft was designed with 2 solar panel wings. Only one opened. The left panel remained jammed shut, wrapped around the hull. This single failure triggered a domino effect. With only half the power, the ship's systems began to starve. Worse, the asymmetry made the craft lopsided in the thin atmosphere. Komarov tried to orient the ship to the sun to charge the dying batteries, but the sensors failed. Soyuz 1 began to spin. Inside the cramped capsule, Komarov was fighting for his life. He was spinning wildly, kicking the side of the ship to jar the panel loose, shouting into the radio as the lights flickered and died. Ground control finally realized the mission was hopeless. They canceled the launch of Soyuz 2, saving the 3 men on the ground. But Komarov was alone. He had to come down. Against all odds, fighting vertigo and equipment failure, Komarov managed to manually align the ship for re-entry. He survived the heat of the atmosphere. He made it through the fire. He was minutes away from safety. But the curse of Soyuz 1 was waiting. At 23,000 feet, the main parachute release fired, but the chute didn't deploy. It stayed stuck in its container, compressed by a design flaw explained by engineers months prior. The backup chute fired automatically, but it tangled with the drag chute. Soyuz 1 plummeted to Earth at over 300 miles per hour. There was no braking, no drag, just a 4-ton meteorite of metal and flesh. According to accounts from NSA listening posts in Turkey, Komarov's final moments were filled with rage. He was reportedly heard cursing the officials who had put him in a botched spaceship. He knew he was dead. The impact near Orenburg was so violent it flattened the capsule and ignited the retro rockets. When recovery teams arrived, they found only a smoking crater and a lump of molten wreckage. Vladimir Komarov had saved his friend, but the deaths marked the Soviet space program as broken. The Silent Death, Soyuz 11. It took 4 years for the Soviets to return to the stars. In June 1971, they launched Soyuz 11. The crew, Commander Dobrovolsky, Flight Engineer Volkov, and Research Engineer Patsayev, had a new destination, Salyut 1, the world's first space station. This mission was the redemption the Soviets needed. For 22 days, the crew lived in orbit. They conducted experiments, broadcast live television to the world, and proved that humans could withstand long-duration spaceflight. They were heroes. On June 29th, they undocked from the station to return home. They were exhausted but happy. The mission had been flawless. The deorbit burn was perfect. The capsule separated from the service module and plunged into the atmosphere. The parachute opened beautifully. The landing engines fired. The capsule touched down gently on the steppes of Kazakhstan. It was a picture-perfect landing. Recovery helicopters touched down nearby. The ground team rushed to the capsule, expecting to pull out 3 celebrating cosmonauts. They knocked on the hatch. Silence. They opened the hatch. The 3 men were strapped in their seats. They looked peaceful, as if they were sleeping, but their skin was a dark blue. They were dead. The investigation into this incident uncovered a tragedy of millimeters. When the descent module separated in orbit, the explosive bolts fired with too much force. The shock wave jarred open a tiny pressure equalization valve. This valve was only supposed to open near the ground to equalize air pressure. Instead, it opened at 105 miles altitude, in the vacuum of space. Disaster struck in silence. The air inside the cabin was sucked out in just 112 seconds. The crew would have felt their ears pop violently. Fog filled the cabin as the temperature dropped. Patsayev was the closest to the valve. He unstrapped himself and tried to close it manually. He fought the fading light of consciousness, but hypoxia is swift. Explained. Within 20 seconds, they passed out. Within 2 minutes, their hearts stopped. They died of suffocation while technically still in space. The tragedy of Soyuz 11 changed spaceflight forever. It is the reason why astronauts today wear bulky pressure suits during launch and re-entry. If the crew of Soyuz 11 had been wearing suits, they would be alive today. But the capsule was too small, so they flew in tracksuits. A design compromise that caused 3 preventable deaths. Frozen warnings. Challenger STS-51L. By 1986, America had grown comfortable with space travel. The space shuttle was a reusable truck, a symbol of routine access to the stars. Mission STS-51L was special. It carried Krista McAuliffe, a high school teacher. Millions of children tuned in to watch, expecting an education on orbit. But behind the scenes, a disaster was brewing. A cold front had hit Florida, dropping temperatures to 18 degrees Fahrenheit. Ice covered the launch pad. The night before the launch, engineers at Morton Thiokol, the company that built the solid rocket boosters, were in a panic. They knew that the rubber O-rings used to seal the rocket joints would fail in the cold. If the rubber was too hard, it wouldn't seal. If it didn't seal, burning gas would escape. In a heated teleconference, the engineers pleaded with NASA to delay. They presented the data. They warned of a catastrophe. But NASA was under pressure. The schedule was tight. Managers were impatient. They overruled the engineers. They launched anyway. At 11:38 a.m. on January 28th, Challenger lifted off. It looked beautiful. But at 0.6 seconds, a puff of black smoke appeared on the right booster. The incident had begun. The O-ring had failed. A jet of flame began to burn through the strut holding the booster. At 73 seconds, the strut gave way. The booster swung inward, piercing the external fuel tank. The massive tank, filled with liquid hydrogen and oxygen, collapsed. The vehicle didn't just explode, it was torn apart by aerodynamic forces. The sky filled with white smoke. But the horror of Challenger is not the explosion. It is what happened after. The crew cabin was built to be tough. It survived the breakup intact. It was thrown clear of the fireball, arcing up to 65,000 feet before beginning to fall. When investigators later examined the wreckage, they found that emergency oxygen packs had been manually activated. The crew was alive. They were conscious. Pilot Michael Smith's final recording was just, "uh-oh," spoken after the breakup began. For 2 minutes and 45 seconds, they fell. They sat in their seats, breathing emergency oxygen, watching the ocean rush up to meet them at 200 miles per hour. The Challenger disaster wasn't just an accident. It was a failure of management. It was a lesson that you cannot negotiate with the laws of physics. The impact with the water resulted in 7 deaths. The foam strike, Columbia STS-107. 17 years later, NASA had seemingly forgotten the lessons of Challenger. The culture of safety had eroded. Normalization of deviance had returned. On January 16, 2003, the shuttle Columbia launched. 81 seconds into the flight, a piece of foam insulation, light as a pillow but moving at supersonic speeds, broke off the fuel tank. It smashed into the leading edge of the left wing. Ground cameras saw the incident. Engineers were worried. They knew the wing was made of carbon panels designed to protect the ship from the heat of re-entry. If a panel was cracked, the ship would burn up. The engineering team begged NASA management to ask the Department of Defense for satellite images of the wing. They needed to see the damage, but management refused. They worried about the schedule. They worried about the cost. One manager infamously said, "Even if there is damage, we can't do anything about it, so why worry the crew?" So, the 7 astronauts of Columbia spent 16 days in orbit, conducting science and enjoying the view, unaware they were flying a dying ship. On February 1st, Columbia began its return. As it hit the atmosphere at Mach 24, the heat shield did its job, except on the left wing. Superheated plasma, hotter than the surface of the sun, entered through the hole the foam had made, explained. It melted the wing from the inside out. Sensors began to fail. The ship fought to stay level, but the drag was too intense. Over the skies of Texas, the wing snapped off. The Columbia disintegrated, scattering debris over hundreds of miles. The crew died instantly, but their deaths were preventable. The foam strike was a known issue. The refusal to get satellite images was a choice. Once again, bureaucracy had trumped safety. The Edge, X-15 Flight 3-65-97. Before the shuttle, there was the X-15, a rocket with wings designed to fly to the very edge of space. It was dangerous, experimental, and flown by the best pilots in the world. On November 15, 1967, Major Michael Adams strapped into the X-15-3. He was dropped from a B-52 bomber and ignited his engine, rocketing up to 266,000 feet. He officially crossed the boundary of space. But in the vacuum, things went wrong. An electrical disturbance knocked out his control system. The incident escalated quickly. The plane began to drift sideways. Adams, disoriented by vertigo, couldn't tell which way was up. The X-15 entered a hypersonic spin. Imagine spinning at 3,000 miles per hour. As the plane fell back into the thick atmosphere, it was flying broadside to the wind. The G-forces spiked to 15 Gs, crushing Adams into his seat. The human body cannot withstand that. The airframe cannot withstand that. The X-15 shattered in mid-air. Adams was found still in his seat in the Mojave Desert. He was the first American to earn his astronaut wings posthumously. His story is a reminder that the boundary between the atmosphere and space is a jagged, deadly line. Vladimir Komarov. The crew of Soyuz 11. The Challenger 7. The Columbia 7. Michael Adams. Why do we look back at these tragedies? It isn't to dwell on the horror, it is to remember the cost. Space is a vacuum that wants to kill us. It is radiation. It is extreme cold. It is extreme heat. It is an environment where a single loose screw or a frozen O-ring can mean the end. But despite the fire and the fear, humanity keeps going. We learn, we redesign, we fix the O-rings, we reinforce the heat shields, we wear the pressure suits. Every safety protocol in the manual today is written in the blood of those who came before. They did not die in vain. They died pushing the envelope of what is possible. They paved the road to the stars. If you found value in this history, please like the video and subscribe for more education. And tell me in the comments, which of these stories had you never heard before?